Okay, question number 6 in Jan 2018. So we will discuss this integration question as well. Okay, so we'll go to question number 6 now. Let's read the questions. I have brought the rules here. The curve shown in figure 2 has equation y square equal 3 tan x over 2 and x values are between 0 and pi, y greater than 0. The finite region R shown shaded in figure 2 is bounded by the curve, the line with equation x equal pi over 3, the x-axis, and the line with equation x equal pi over 2. The region R is rotated through 360 degrees above the x-axis to generate a solid of revolution. Okay, so this region R, you're only rotating the region R. So I told you when you're taking these kinds of regions, these two open ends are what gives you the circular faces. Can you remember? So just create the two circular faces at these two ends. And then you create, and then you get the 3D object here. This is the 3D object. Okay. So then they tell you that it's rotated to 360 degrees above the x-axis to generate a solid revolution. Show that the exact value of the solid volume of the solid generated may be written as A times ln 3 over 2. Okay. So what is the equation for volume of revolution in Cartesian form? You can see here your equation is Cartesian form because you have y in terms of x. So volume of revolution is volume equal pi y square with respect to x, and your limits, your x limits starting from here, the x limits are given as pi over 3, pi over 2. Okay, so they've given the x limits as pi over 3, pi over 2. Okay, so you might be wondering, are these theta limits? No, it's the x value because it's marked on the x axis. So you can mark here without fear. This is pi over 3. The top limit is pi over 2. Then I get here volume equals pi. Y square is directly given to you. You don't need to square the function because this is already y square. Okay, so 3 tan x over 2 or 3 tan x over 2 in other words is half x. Shall I write as half x? Okay, and with respect to x, limits are pi over 3, pi over 2. And then what do we do? Now it's time to integrate. So when you're integrating tan, so the tan integration, yeah, how do we integrate tan? So I think tan integration is given in your formula book. Am I correct to say that tan x integration is given to you as ln, what was the integration? ln sec x, isn't it? Tan integration is given to you. It's there in the formula book, in the P4 integration or in the P3 integration page. Isn't it? Tan x integration is ln sec x. However, you need to have the rule this ax plus b order in effect. Okay. So if you have a coefficient of x, okay, so these rules will be in effect, which means if you have a x coefficient or a linear function, so basically tan ax plus b, the rule will be ln sec ax plus b, and remember you have to go 1 over a. So this is how the rule works. Okay. So if you have a coefficient of x here, you have to divide by that coefficient of x and ln sec ax plus b. Okay, are you with me? So then how does it work here? Volume equals pi times 3. I'll bring the 3 out. 3 is a constant. You can bring it out of the integration. Tan half x. So the a value is half here. Can you see tan half x? A is half. So when you integrate, it's 1 over half. Do you agree? 1 over a. A is half here in this case. My a value is half. 1 over a. So 1 over half. Ln 1 over ln sec half x. It's sec half x. It's extremely important you realize it's sec half x here, because it's not just sec x, because your original the angle here is half x. It's going to be sec half x. Okay, there's no plus b here, so it's just the x coefficient, sec half x. Tan half x is 1 over half ln sec half x. Okay, and then make sure you give your limits. You could bring the, let's keep the 1 over half outside. From pi over 3 to pi over 2. And then I end up getting here volume equals 1 divided by half, it comes up as 2. So pi into 3 into 2 is 6 pi. 6 pi times ln, let's input the limits, ln sec half x from pi over 3 to pi over 2. Are you with me? So we end up getting here, let's input the limit 6 pi times ln sec half into pi over 2. So that's ln sec pi over 4 minus ln sec half into pi over 3 is pi over 6. Are you with me? So how do we get the answer here? 6 pi times ln, you know, sec is 1 over cos, right? So it's cos ln inside the bracket, it's 1 over cos pi over 4 minus ln 1 over cos pi by 6. Okay, so how does this work? 1 over cos pi by 4, can you type in the cal? The cal should be in radian mode. Okay, with the calculator in radian mode, you can type 1 over cos pi by 4. And I get root 2. So 1 over cos pi by 4, the direct answer is root 2. So ln root 2. Can you understand? This is ln root 2 minus 1 over cos pi by 6. 1 over cos pi by 6 will be directly 2 root 3 over 3. So that's going to be, it's inside the ln function. So ln 2 root 3 over 3. Are you with me? And then we'll simplify, you know, when you have a subtraction of two logarithms, it becomes a division under a single logarithm. Are you with me? So when you have a subtraction of two logarithms, ln a minus ln b is ln under a single logarithm, it becomes a division. So ln root 2 divide by, shall I write like this? Root 2 divide by 2 root 3 over 3. So volume equals 6 pi times ln root 2 into 3 over 2 root 3. Are you with me? So how does this simplify? This becomes ln 3 root 2 over 2 root 3. Do you agree? This you could rationalize, multiply up and down with root 3 because I want to give the answer in terms of, can you see, show that has ln 3 over 2. So I rationalize multiplying up and down with root 3 to remove the root in the denominator. So I get volume equals 6 pi times ln. What do I get here? 3 times root 2 into root 3 is root 6 over 2 into root 3 into root 3 is 3. Are you with me? I can cancel out 3 here and I get volume equals 6 pi times ln root 6 over 2. Okay, actually, you know what? The show that tells us to get a 3 over 2, isn't it? The show that is asking us to get a 3 over 2, but you can see when I go in this manner, I'm not getting a 3 over 2. Okay, so let me do a quick change here. Instead of going in this path, okay, so let's slightly deviate. Volume equals 6 pi ln. You get here 3 root 2 over 2 root 3, isn't it? Okay, so then what you can do here is, what you could do here is, if you type it in the cal, you would get this root 6 over 2. So instead of going down in that path, to create the 3 over 2, okay, so you have to be a little bit creative here. Now you do realize you create 3 by getting root 3 into root 3. Do you agree? 3, you can create 3 by taking root 3 into root 3. So I'm going to do something like that to this 3 and 2. Okay, just look why I'm doing this. So 3 is root 3 into root 3. And then you have root 2. Okay. And then 2 is root 2 into root 2 times root 3. And then you can cancel out, right? So you can cancel out a single, I hope you can understand what I did here. The 3, I wrote it as root 3 into root 3 because it gives me the 3, and this 2 here, I wrote as root 2 into root 2. And then you can see like basically have I done any change to the sum? So you can see here numerator. Okay, so here the numerator is the numerator 3 is root 3 into root 3. Denominator the 2 is root 2 into root 2. The remaining parts I have written exactly as it is without doing any change to the sum. Do you agree? So now I can cancel out. Can you see I can cancel out a single root 3 to a single root 3. I can cancel out a single root 2 to a single root 2. And can you see what I create here? 6 pi times ln root 3 divided by root 2. Can you see? And this I can take it under a single power because both of them are roots. It's power half. So it's 3 over 2 to the power half. Do you agree? Because it's 3 over 2 entirely to the power half. That power half in the logarithm, you can bring it out. So, you know, the power comes front. So 6 pi into half is 3 pi. Okay, so again, what I did here is this half comes out. These are extra steps I'm writing. You don't need to write them directly. So volume is 3 pi times ln 3 over 2. So what did I do here? Because this root is common to both, it's directly 3 over 2, the whole thing root. Root means the power half. So power half when I bring it front, because it's a logarithm function, I can bring the power half front. It's a logarithm rule you learn in P2. You bring the power half front, 6 pi into half is 3 pi. 3 pi ln 3 over 2. So this is the show that. Show that says to get the answers A ln 3 over 2. So the A value is 3 pi. The A value is 3 pi. Are you with me? Okay, so this is the answer.